You're about to listen to a new episode of Audio Signals. Get ready to take a journey into the known, the unknown, and everything in between. Recorded at no specific point in time nor space, ITSP Magazine's co-founders Marco Ciappelli and Sean Martin follow their passion and curiosity as they venture away from the intersection of technology, cybersecurity, and society to discover new stories worth being told. Knowledge is power, now more than ever.
Nintex is the global standard for business process management and automation. The Nintex platform helps their clients accelerate progress on their digital transformation journeys by quickly and easily managing, automating, and optimizing business processes. Learn more at nintex.com.
Blue Lava is the first business platform for CISOs to manage their security program. Blue Lava guides security leaders to effectively measure, optimize, and communicate their security program with confidence and ease in one platform. Learn more at bluelava.net.
Marco.
Sean, welcome back.
I know.
I was here on Audio Signals and I was talking to myself.
Sometimes I let you fly solo.
It was more like an echo signal that I was getting.
An echo signal?
My own feedback.
Did it sound like a whale or a dolphin? I think the last one was through
that
the ocean.
Too, about ocean sounds and music.
I'm so sad I missed that one.
Yeah, I think you would have liked that. But I think you're going to like this one too.
I will like this one. I know that for a fact. And it's a crypto of a different kind than my background has rooted me in. So there's cryptography, right? Protecting data. But the inner bits of that, which I'm sure our guests will help us better understand, have also been used to generate cryptocurrency. And obviously there's a lot of hype around that, and it's pretty much prevalent and used, seems like, for everything. Like, you can buy a house with cryptocurrency. You can.
I don't know if we're there, but
I'm pretty sure I thought I saw that. I don't know.
Not everybody's going to allow you that, I guess. But that's why we have somebody that may have some answer to this. But mostly, I have done few of the podcast on Audio Signal lately, where I'm usually the dumbest person in the room or in the conversation, and lately I'm even really the one that doesn't know enough to be in the conversation. But I like it because I try to get this basic understanding of the topic. And today with Robert, which we met through the Mentor Project, yet another Mentor Project fellow that we got connected through that fantastic organization. He's going to tell us a little bit of what is cryptocurrency, how it works, what can be done, what cannot be done. And because it's already 2 minutes that we're blabbling, the two of us, Robert, welcome to the show.
Well, thank you for having me, Marco and Sean. It's a pleasure to be here.
Yeah, and first of all, congratulations. I know you're almost to the graduation of your study. Although, as I mentioned before we started, based on your bio, it seems to me like you have already done way more than what I've done, and I graduated a long, long time ago. So a little bit about yourself.
Sure. Well, I'm an associate engineer with the Filecoin Foundation, where I work on education projects, including a course we're launching on July 11th that runs for 4 weeks that is basically blockchain software engineering, which I'm sure we'll talk about a little more later. But yeah, I'm wrapping up my time at the University of Pennsylvania. I'm an electrical engineering and finance background. Before coming to Filecoin Foundation, I had launched a couple of startups. The first one is called rePurpose, and that won a big grant and launched in India and is still going strong. And that is a plastic credit platform. So it's kind of a social impact. And I would encourage anyone who's interested in that type of issue or environmental issues, to go to rePurpose.global to learn about what they're doing. I'm no longer involved, but they're doing great. And then the second startup we called it Alphagora, and this was an SEC registered robo advisor for client cryptocurrency portfolios. So we were doing actively managed quantitative strategies for our clients, and so that's the story there. So
there you go. And talking about story, that's going to be exactly the first topic. Like, I'm assuming a lot of people that are listening to this episode, they heard, of course, about Bitcoin, Ethereum, and all of that cryptocurrency. I don't know how many are very knowledgeable about this. So if you can give us a little bit of an introduction to the topic and how we got from not having cryptocurrency to having cryptocurrency, that'd be great. Sure.
So I actually, some people joke that when I talk about this, I start from Genesis, because I go all the way back and I talk about vacuum tube computers and all this stuff. But perhaps just for some historical background context, I'm sure your audience will be very familiar with Richard Feynman, the great professor from Caltech, and his amazing lecture out of nowhere in the late 1950s called Plenty of Room at the Bottom, where, at that time in America, we were trying to build big things. We were trying to go to space. We were trying to beat the Soviets, go to the moon. And he was talking about small things. Can we build tiny robots? Can we build tiny motors? Can we write the entire Encyclopedia Britannica on the head of a pin? And that talk was the catalyst for the Silicon Run processes that make our modern computer chips. And from that, we get the transistor. So we can move from vacuum tubes to much smaller hardware that represents a 0 or a 1, a binary bit. And, naturally now our iPhones have as much, our iPhone, basically, if our iPhones were a vacuum tube computer from the 1940s, they would have the same. You would need a vacuum tube computer that is the size of the Pentagon building in DC to have the same amount of computation that we have in our pocket today.
I do have one of those, thankfully.
Yeah,
you do? You carry it with you?
I carry it around with me, yes. It's in a backpack.
I believe it. But the reason why I kind of go back to this is I think, oftentimes when we talk about cryptocurrency, people go to the markets and then all of a sudden the plot is immediately lost. And I think what makes Bitcoin so interesting, naturally is not the commodity market that has developed around it, but actually the technological and financial innovation that has at least the early adopters found to be so compelling. So what are those things? So the first, maybe we'll start with a little bit of how you can get a transaction kind of through on the Bitcoin network. So someone wants to send a Bitcoin transaction. This is a peer-to-peer transaction in that, let's say Marco wants to send Sean 1 Bitcoin. Well, that transaction, the transaction details are sent to kind of a waiting area. And then there is a competition to add that transaction to the ledger, which we call the blockchain. And that competition looks something like this. There are thousands of computers all over the world that are, quote unquote, maintaining the Bitcoin blockchain. And they try to take that transaction detail and put it in a bit of memory that they've created on their computer. We call that bit of memory a block, and you can have multiple transactions in that block. You can kind of see how we're getting the name blockchain. So this is where the block comes in. And then what ends up happening is that computer, which has the bit of memory, which we call a block, and includes this transaction that's 1 Bitcoin sent from Marco to Sean. It does a number of things. The first thing it's going to do is it's going to check to make sure that Marco has not previously spent this Bitcoin that he's trying to send to Sean. And then the computer is going to do something that we call proof of work. And effectively what the computer is doing is it's guessing a random number to some cryptographic puzzle. And in doing so, it's spending electricity. So the reason for that will become very, very clear in just a moment. So where are we so far? So Marco wants to send a Bitcoin to Sean. It goes to this global waiting area. We call it the mempool. Thousands of computers are competing to try to take that transaction data and put it in a bit of memory that they create. That bit of memory is called the block. They then check to make sure Marco hasn't spent this Bitcoin before, and they solve this cryptographic puzzle by guessing some random number.
Is it okay if I pause you quickly, Robert?
Yeah, sure.
There's a term that I often hear, mining.
Yes.
And how does it, is now the appropriate time to ask that? And is it related to this?
Yeah. So I just described the mining process.
Okay.
So that is what this computer is that's your miner, is this computer that has created this block. So then what's going to happen is the miner that just created the block and has Marco's transaction to Sean in it, the miner is going to propose the block to the thousands of other computers on the Bitcoin network. And the other computers are going to more or less signal their acceptance of the block and in turn the approval of the transaction by building the next block chronologically that references this block that this miner just created as the previous block. So that's how you get them chained together. So what are the other miners also checking for? Well, they're checking to make sure that Marco's Bitcoin has not been previously spent. And they're checking to make sure that the nonce is correctly solved, that it's the nonce being the cryptographic puzzle, that it's the correct solution. Now, why would we want both of those things? Well, that's the real innovation of Bitcoin. You are checking to make sure that the Bitcoin hasn't been previously spent, because in kind of legacy financial systems or banking systems, we had this issue of the double spend problem, where people could, because their accounts were siloed from each other, could actually get away with sending the same $100 to 2 different accounts. And this is naturally a really big problem for a number of reasons, not only because it ends up costing the bank money that this account never had, but also because, effectively that account is putting money to the money supply that never existed.
The solution to that problem was time, right? You have to wait for one or the other transactions to complete, delaying the one or the other transaction, right?
Exactly. So the time machine, now the bank has to, basically 3 days later, the bank realizes that, this person spent money they didn't have, so naturally there are some manual solutions for this, but Bitcoin kind of automates this solution to the double spend, because any block that has a transaction with Bitcoin that's been previously spent in previous blocks, the block will be rejected. So the other miners will not start building the blocks that reference the proposed block. So that's the first really interesting innovation of Bitcoin. And by the way, it's probably worth me mentioning how this is accomplished. And this is a quote from Satoshi Nakamoto, the anonymous creator of Bitcoin's white paper, is that Bitcoin is actually defined in the white paper simply as a chain of digital signatures. So every time a transaction is sent from one party to another, Marco sends a Bitcoin to Sean. Well, Marco is actually signing with a digital signature to send that Bitcoin over to Sean. And that Bitcoin that's being sent is basically the whole history of all of the signatures from the first wallet that ever had that Bitcoin, from one wallet to the next. And Sean, you being a cryptographer, we could talk about public-private key encryption and how that's accomplished, but naturally, you could imagine the public key is the public address. So Marco is sending the Bitcoin to Sean's public address, and then Marco is signing using the private key that's associated with that public address. And that's basically what a Bitcoin actually is. It's a chain of digital signatures. So that's the first innovation, is that Bitcoin has solved the double spend problem through this way of checking the previous signatures to make sure it hasn't been previously spent. And then the other interesting innovation that this mining process, and really it's two innovations that the mining process introduces, one of which should be abundantly clear. And the other I haven't talked about yet, because we haven't talked about why anyone would even mine Bitcoin to begin with. So the first innovation is that Bitcoin presents more or less a solution to the Byzantine generals problem. We have thousands of computers all over the world that agree on the current state of the Bitcoin ledger at the same time. And that is something that is very, very interesting for those who are interested in network systems and how computers interact with each other and how you can store on two different computers the same exact file. Well, this mining process kind of enables some type of solution to this Byzantine generals problem, where all of the computers, really a consensus, a majority of the computers at any given time will agree as to the current, which block is the most recent block and the current state of the blockchain. The third innovation that this mining process gives way to, and maybe why the commodity market has developed around it. And again, this is not financial advice, and certainly I am not saying any of this in my capacity as working for Filecoin. I'm not saying this in my capacity working for Filecoin Foundation, but just from an academic standpoint, any course we teach, this has to be mentioned, is that, miners are actually, they're doing this process because they're earning newly minted Bitcoin that hasn't been in circulation yet. So that is the kind of incentive to be a Bitcoin miner. They're not just spending electricity to solve that cryptographic puzzle for no reason. They spend electricity, they earn Bitcoin if their block gets approved. That is the business that they're running. And so that's why you hear a lot about how, Bitcoin miners they're trying to, use really, really cheap electricity, or, they're in a jurisdiction that has really cheap electricity, or, some college kids in a dorm room, turn their dorm into a Bitcoin miner because, their college isn't charging them an electrical bill, or they're setting up their own solar panel farms to mine this Bitcoin. That's the business model. Spend electricity and earn Bitcoin. Now, there's two things we should talk about on each of those, and then I will, maybe hand the mic back to both of you. But, why require that there's some electrical spend through the solving of this cryptographic puzzle? That's the first question. And the second question is, okay, newly minted Bitcoin, what's the deal with the money supply? How does that work? So maybe we talk about the latter first. Every 210,000 blocks, the Bitcoin mining reward, this is the amount of Bitcoin that the miners are going to earn as a thank you for minting this new block and approving these transactions. The miner's reward actually cuts in half every 210,000 blocks, and that's approximately every 4 years. So it started at a 50 Bitcoin mining reward, And then 4 years later, it cut down to 25. Then 4 years later, it was 12 and a half. And right now it stands at 6.25. So what this means for the money supply of Bitcoin is that the total Bitcoin in circulation actually follows this kind of inverse log function. And eventually we're going to get to a maximum of almost 21 million Bitcoin. So what is this supposed to do? Well, this is supposed to introduce some level of scarcity to Bitcoin. So that's maybe why it's interesting. And, we could talk about kind of the grievances around central banking and what was actually in the genesis, the first block of Bitcoin, what Satoshi Nakamoto, there was an article that Satoshi Nakamoto references about the central banks in the 2008 financial crisis. But we could come back to that. But there's definitely some of that, there's definitely some of that motivation about Bitcoin to create some asset that has scarcity and is maybe deflationary rather than, the currencies that our central banks manage, which have some level of inflation. The more independent the central bank is, the lower inflation tends to be. But we're living in an inflationary environment right now. So I think your audience is very familiar with what, all the spending that's gone on the past 2 years, all the printing of the money, and now we're facing the effects of this. So that's the first thing that's interesting about Bitcoin is this money supply. And then the second thing is why require that the miners actually spend that electricity? Well, in spending the electricity to solve this cryptographic puzzle, this nonce, they're actually spending money. So as a consequence, it's actually cheaper for a Bitcoin miner to simply add one block and only solve one puzzle than to try to solve 5 puzzles or 10 puzzles and try to reverse blocks and try to rewrite the history of Bitcoin. You could imagine there's no central authority here. There's thousands of computers all over the world that are competing to add these blocks. That's thousands of computers that don't know each other that are helping maintain the ledger. There's no one bank that can manage transactions. So naturally, if you're using Bitcoin, you wouldn't want a transaction. Let's say Marco sends this Bitcoin to Sean today. Well, in 5 days, you're going to want that transaction to still be there. So this cryptographic puzzle that requires electricity spend actually ensures that more or less there's no rewriting of history, that the transactions are immutable and they can't be reversed.
So I have a quick question, which is, if my dog allows me to talk, why do we have different kind of cryptocurrency? Like, it sounds already complicated the way it is, but like, how is that Ethereum came into place and competing maybe with Bitcoin, and then there is always a new one that is on the same blockchain and so forth?
Sure. Bitcoin is the first cryptocurrency as we understand them that uses this blockchain method of approving transactions and maintaining the ledger. So Bitcoin's the first. I will say there are pre-Bitcoin, maybe we call them digital currencies or virtual currencies like Hashcash and eGold, some of which are actually referenced in the Bitcoin white paper. So, and you could also think, there are currencies that were involved in games before 2008 in video games. So, digital currency experimentations have been going on since before Bitcoin came about. That being said, after Bitcoin, what made Bitcoin the most compelling was this mining method and this decentralized nature. It really accomplished something that the previous, attempts were not able to. But so what's interesting also about Bitcoin is it's an open source project. So anyone can become a miner. Anyone can open a Bitcoin wallet and transact with Bitcoin. And anyone can serve as a software engineer and volunteer their time to contribute to the Bitcoin software. And you can imagine, someone has an interesting idea for the Bitcoin software. Maybe they want to, just totally random examples, but maybe they want to increase the size of the Bitcoin block. Remember, I said that's a bit of memory. Maybe it's helpful to, I'm not taking a side either way, but maybe a software engineer thinks it's helpful to increase the size of the block, or maybe they think it's helpful to increase the total money supply or change how, the miner's reward is. All that would take is a software engineer proposing the code, and then a consensus, more than half of the miners basically saying, okay, we'll take the software update. So Bitcoin is open source. And what that means is other teams, other software engineers were able to take Bitcoin and innovate on top of it, and create whole new projects that use a lot of the same technologies, but maybe push the boundaries a little further. Naturally, Ethereum is probably the best. Ethereum probably the most commonly known. Ethereum, kind of like Bitcoin, I think what makes it different is that on top of the Ethereum blockchain, you actually have a state machine. And this is more or less, in the early days of Ethereum, it was marketed as the world computer, that this was, the world computer. And why is that? Well, the state machine is basically, it's a virtual machine built on top of a blockchain. And what the Ethereum virtual machine allows you to do is to write these things called smart contracts. So imagine Marco and Sean, maybe they like to follow Formula One. And Marco, okay, all right. So Marco is...
How did you know that?
Marco being Italian, he's probably rooting for Ferrari. And Sean is, let's go with Team Mercedes here. And, Marco and Sean, they want to place a bet. And they want to, Marco says, okay, I bet 100 Bitcoin that Ferrari is going to win the Monaco Grand Prix. And Sean says, okay, I'll bet 100 Bitcoin that Mercedes is going to win the Monaco Grand Prix. Well, what you would have to do, and, naturally, I know nothing about gambling, but let's just say for all intents and purposes, what the two of you would have to do would either you have a gentleman's agreement, or maybe you don't know each other and you get an attorney to draft a contract, or you go to a gambling house and you want to put that Bitcoin in escrow and have the gambling house automate, basically after the race, the gambling house sends the money, to the winner. Well, the attorney for the contract is going to cost some money, and the gambling house might want to take, some fee for their escrow services. What Ethereum would allow you to do is you can write a smart contract where each of you would send, instead of your Bitcoin, you would send your 100 Ethereum to the smart contract, which has a public address itself. And the smart contract is a bit of code that's exactly what it sounds like. It's a contract that says when Ferrari wins, Marco will get all 200 of this Ethereum. And when Mercedes wins, Sean will get all 200 of this Ethereum. And, more or less, you would have some way of, scraping the internet for that data of who won the race. And once that data is inputted to the smart contract executes, and that 200 Ether that was held in escrow automatically goes to the wallet. Let's say Mercedes wins. Well, congratulations, Sean. You get the 200 Ether. So you can imagine.
I like this podcast.
Yeah, exactly. Yeah, you get 200 Ether. You could imagine, gambling. We just use this as an example, but you could imagine any type of business logic can be automated with the smart contract, and there are many examples we could talk about. But you could have all sorts of different things. For example, we call these maybe well, okay, maybe I'll get into this a little bit, but in 2016, we had the first DAO. Now, right now, a lot of people are probably hearing a lot about different, this is DAO, DAO. So this is an acronym that stands for Decentralized Autonomous Organization. So there are a few that are, you know, kind of popular. I won't name them, but, you know, certainly are known to the industry. But the first DAO, what we call the Decentralized Autonomous Organization, was from 2016. And what this DAO was meant to do, basically you'd have, you know, hundreds, thousands of investors all over the world, and you would send your ether to the DAO. Now, this DAO is a collection of smart contracts. What happens is you send your ether to the DAO, and based on the proportion of total ether sent to the DAO, the percentage of ether you sent, that is the percent of vote you get. And then, you know, with people you don't know all over the world, people would vote on what projects to invest this ether in, and you would have your proportional vote. Now, what happened with this DAO is that, you know, this is the early days of Ethereum, and we didn't have smart contract auditing or even, indexing, public indexing of the blockchain that made it easy for people to look at what was going on. So what ended up happening was a software engineer, you know, they call it the DAO hack, but it really wasn't a hack at all. It was just an exploit of, you know, maybe hastily written code. Well, one person was able to just siphon off, you know, somewhere, I think $160 million or something of that money that was sent to the DAO. So, you know, what this led to was big controversy. A lot of people lost money. Vitalik, the creator of Ethereum, and the, you know, the Ethereum software engineers said, okay, you know, we have a choice here. We could let this theft stand, or we can copy the whole Ethereum blockchain up until now, except we'll only go up to the block right before this DAO was launched, and we'll just start building on another blockchain that is a copy that has everything up until this DAO was launched, and we'll just go from there. So that's what they ended up doing. So that latter version of Ethereum, which today is called Ethereum, and this is the Ethereum that Vitalik and the Ethereum Foundation and the Ethereum developers mostly support, and where most of the applications, by the way, are built. This copy of the original Ethereum is actually, it's actually not the original Ethereum. The original Ethereum is called Ethereum Classic, and Ethereum Classic still has this theft on the chain. So this is, you know, something that's very interesting about the open source nature, by the way, of blockchains, that you could copy these things. And
those revisions, those I know them as branches in traditional coding terms. What are those called? Do they matter for the general cryptocurrency user?
Yeah. So these are called forks. So I guess we'd call this type of fork a hard fork, but more or less you have, you know, let's say you have a group of miners that want to accept a software update, or, you know, just want to start building on a different version of the blockchain that they're building on. Well, some of them could just declare that they're going to start building on a different chain. And if enough miners are building on both chains, well, then guess what? You get to keep both chains. So this happens all the time. You know, we have Bitcoin Cash is some type of hard fork of Bitcoin. And but what's interesting is if you had a wallet on the original Ethereum Classic up until the block before the DAO was launched, well, when the blockchain is copied to make the new Ethereum, everyone who had a wallet on the original Ethereum also has a wallet on the new Ethereum. So this is, you know, some people, when Bitcoin Cash was created and forked from the original Bitcoin, well, they got some free Bitcoin Cash in their, you know, they have wallets, you know, so this is a very interesting phenomenon.
Tell me, I don't know if it's connected, I'm assuming, but when you look at the metaverse or other gaming. I mean, I see that they create their own currency.
Right.
So Base, I read sometimes on the Ethereum blockchain. Is that still considered a fork, or how do you, like, what's the function of that? Why not using Ethereum? Why not using, and making a proprietary currency for that?
Yeah, that's a great question, Marco. So I can't speak to the metaverse, but actually on Ethereum, with smart contracts on Ethereum, you can create your own currency, and they're called tokens. And there are actually there are standards. There are smart contract standards. So you would write a smart contract, and there are smart contract standards for this. And your tokens can be one of two options. They could be fungible, so that naturally these things are one token. Let's call it Marco coin. One Marco coin equals one Marco coin. You could divide it into as many decimals as you want, and it's fungible. This is an ERC20 token, so these are fungible tokens. And maybe many in your audience may know these fungible ERC20 tokens were used for the ICO craze of the 2017, 2018 ICO craze. So that's what a lot of these were used for. But you can create Marco coin with a smart contract. And now you might want to say, where does the smart contract come into play? Well, with the smart contract, you can choose either to airdrop your Marco coin for free to a set of wallets of your choosing, or you can, just like with the DAO, it took Ether as an input and gave those wallets a proportional vote. Well, you can take Ether as an input to the ERC20 contract, and then in return, send an exchange of Marco coin back to the wallet that sent the Ether. So that's what these kind of ERC20 tokens are. And those are the fungible assets. So there are many ERC tokens that are used on, that were created and are used on Ethereum for all sorts of reasons. Another reason those ERC20 tokens, these fungible tokens, were created was as a kind of holding, until it could be exchanged for a actual cryptocurrency on a different blockchain. So they could be like redeemable tokens, basically redeemable for a one-to-one for the crypto once a blockchain, launches later. So that's one thing. And naturally, there are all sorts of issues related to this that I won't get into. But if you have attorneys in your audience, I'm sure they'd love to talk to you about the securities laws and what it has to do with raising money and how that played out in 2017 and 2018. So a lot of interesting cases. The Howey test is certainly relevant, and anyway, but that's, I think, beyond the scope. The other type of currency you could create on Ethereum is the ERC 721 token, which is your non-fungible token. So this is a family of tokens that are each one unique and not divisible. And this is how you have things like collectibles, like CryptoKitties. And Marco, I think it sounds like you were involved with some NFT purchasing.
Well, let's see if I can make some money from my photography or something like that. And I think Sean had the same idea. Then we look at the gas cost to do it. I'm like, I don't know. Am I going to make that money back? So we were trying to figure out things. That's why we know a little bit about it. But of course, we are aware of how the non-fungible tokens, NFTs, is everybody's mouth right now. And I don't know. I mean, I think it's a great thing for artists, from what I understand. Maybe not a good thing if you pay $600,000 for something, and now today is worth $2. But I guess that's the risk of collecting.
Right. Well, what's interesting about these non-fungible tokens is that the token, so this is the the cryptocurrency representation of this art, is on, let's say it's on Ethereum. Let's say you chose Ethereum for your NFTs. Well, the actual art file usually isn't stored on the blockchain where the token is. There's actually a link in the manifest of the NFT to a different platform like, Filecoin, IPFS, where the actual art file is stored. So yeah, there are actual art files that are associated with this NFT, and they're stored on a different platform, but the wallet, the Ethereum wallet, shows that you own that piece of art.
And again, it's a contract, right? It's nothing more than a contract.
It's a contract, but I think I like to talk about kind of non-crypto analogs when we talk about this. Consider the antiquities market.
Mm-hmm.
Provenance is the major issue. But with NFTs, for example, let's say, instead of your NFT representing your digital art file that's stored on Filecoin IPFS, let's say your NFT actually is associated with, some type of antiquity in the real world. Well, guess what? Let's say Marco owns the NFT associated with this antiquity. Let's say he wants to sell the antiquity. He sells it to Sean. He transfers not only the antiquity, whatever it is, but also the NFT to Sean. Well, what did we say Bitcoin was? It's a chain of digital signatures. You can actually go to the Bitcoin blockchain and with any amount of Bitcoin trace all its ownership back to to the Bitcoin's minting. Well, you could do the same with NFTs, and all of a sudden we've created a system where provenance is guaranteed. No one can manipulate the documentation because it's the NFT token. It's blockchains are open and transparent, so we can all see who has owned this NFT previously, and we know the ownership back to the beginning. So this is really a consequential. NFTs are in the news a lot, and there's a lot of modern art, but there's certainly applications for other consequential. There's certainly applications in other areas of art that is consequential, antiquities being one of them. And I think this provenance, it's a unique aspect of the blockchain that makes that possible.
Can you talk to me more about the Filecoin and the storing of the digital art? And I don't know, it could be digital anything, perhaps. I don't know if it's limited to art. What I'm envisioning is, tell me how this works, but I'm envisioning people setting up galleries, right, where perhaps you can display your art in a NFT enabled Filecoin gallery, and I don't know, maybe you charge people to come visit that museum or galleries. I don't know. Well, what's the reason? What's the operational model for this whole system? What's the purpose?
Yeah, or you could have your gallery in the metaverse, right?
Yeah, there's that too. Yeah,
you can get the entire Uffizi museum in there, the Louvre, or
I believe it. So Filecoin IPFS standing for Interplanetary File System. The Interplanetary File System. Okay, well, let me just backtrack. So, on the internet today, we use, people want to set up a website. They probably go to something like AWS, Amazon Web Services, or Google Cloud, and that's where they get all their servers, and that's where they host their website. That's all well and good. The other thing about the internet is that we use on the internet, you may be familiar, obviously your audience knows about this, but we have IP addresses. So these IP addresses are location addresses associated with your computer, your device, your server, whatever. What Filecoin IPFS aims to do is more or less present a different model for the internet, where instead of having location-based address, we have content addresses, and I'll kind of explain what that is in a moment. And instead of having, maybe AWS or Google Cloud or some central, one of three major big players that can host our websites or any of our data, well, anyone can offer the free memory on their devices to host or store information. So what does this mean? So we have the interplanetary file system. This is the hypermedia protocol that allows files to be exchanged between devices on the Filecoin IPFS network. And so this is basically, the communication protocol. Storing or reading files. And then you have Filecoin, which is this cryptocurrency that is kind of a second layer to this platform. So what does Filecoin IPFS enable together? Well, it enables anyone with a laptop and free memory on their device to actually offer that memory for rent. And it allows anyone else who have files they want to store to actually store their files on that person's device and actually rent the space. And Filecoin is the coin that's used for that. And there's, Bitcoin, we call the mining process proof of work. With Filecoin IPFS, we have different proofs, proof of one of which being proof of space-time and the other being proof of replication. These guarantee to the together those guarantee to the person who's renting the space and storing the file that their files are there. And then the storage.
In simple mind like I have, is this a blockchain enabled S3?
It's blockchain enabled, more or less AWS, but anyone can serve as a storage provider. And our storage
distributed,
yeah. So our storage providers are now, we don't, instead of miners, we have storage providers on Filecoin.
It's like an Airbnb.
It's Airbnb for computer memory. That's absolutely right. Absolutely right.
Like, hey, I have an extra, independent entrance little home. I'm going to rent it. You want
it? Absolutely. And so Marco's analogy is spot on. It's Airbnb for, it's Airbnb for computer memory.
But I hope we better warranties and security than Airbnb.
So so that's naturally the blockchain aspect to that, and the transparency aspect to this makes it very compelling. Something of interest is that of all the NFTs, there are over 64 million stored on Filecoin IPFS. So the tokens are maybe on Ethereum, and the actual art files are on Filecoin IPFS. There are some very interesting partnerships that have been developed where big amounts of data are being stored on Filecoin IPFS. I think some of those that are public and interesting are there's the Internet Archive is putting huge data sets on Filecoin IPFS. Harvard's libraries are putting large data sets. New York City is putting large data sets on Filecoin IPFS. So these seem to be the types of use case that IPFS is useful for. Now,
archives,
yeah.
Don't mean to pause you, but how about we talk a lot about healthcare in some of our other shows, and access to medical records. So X-rays and scans, some of it archived, but you want to have it accessible in real time as well.
Yeah. So, Sean, I'm glad you bring that up. Naturally, my knowledge, healthcare in particular is beyond my knowledge, but there are two things I would want to say about records. So I mentioned, one is related to Filecoin IPFS, and one is related maybe to Ethereum or really any blockchain. So with Filecoin IPFS, something that's very interesting is that I had mentioned that instead of the location-based addressing that the internet uses, we use content addressing on Filecoin IPFS. So what does that mean? Every file has a unique identifier instead of it being stored at some unique location. So For example, let's say you have a photo of a beagle. Well, instead of going to puppies.com/beagle.jpg, this beagle photo has some unique, some amount of characters string that represents that photo. And the file is actually, every file has a unique identifier, a unique content address. And this is important because if someone manipulated this beagle photo, for example, they put a birthday hat on this beagle photo, well, guess what? The content identifier is going to change. So there's some level of guarantee and trust about the files being tampered with Filecoin IPFS, and that's one of the main goals. And also, by the way, the content identifier, if you know what file you're looking for, will tell you without you having to open the file something about the file, such that you know the file is what you're looking for, as opposed to on the internet we use today. Let's say you go to www.puppies.beagle.jpg, but you've been tricked and you see a photo of a chihuahua instead, right? So there's nothing related to the naming of the file as to what what's actually at the, what is the file, right? So this is something interesting about Filecoin IPFS. It uses content addressing, and the idea is that it'll make for a more efficient internet. You won't have many redundancies, many different websites hosting the same photo of a beagle. So that's one thing that may be interesting about records, is that this content addressing certainly is a very interesting solution to making sure records are not tampered with.
Yeah, the integrity.
Always
a hot topic.
Robert, I'm gonna stop Sean, because if you could start going in security with him, you're gonna be here for a very, very, very long time. And I, first of all, fascinating. I love the way you simplify and you use metaphor and real case study to understand the whole, ephemeral thing that or abstract concept that we work with, which are very easy for you to understand, and with engineer minds and programmers and people that work in the background. But for the everyday person, I always think that when you bring an example of the everyday life application, it always helps. So number one, you're welcome to come back and talk more with us about specific topic, because of course, we said it's going to be 35 minutes. We're at 50. And we haven't even scrapped the surface. So
right.
I hope the audience is enjoying these, and honestly, you can come back anytime. I know you mentioned a course that you have on July 11th. So I would like for you to take a couple of minutes of what is left here to present that, because of course there's a lot to learn, and I want to give you the opportunity to present that.
Sure. Well, thank you, Marco. I appreciate you allowing me to have a plug. Actually, for the audience, Marco asked me to come on this podcast a year and a half ago, and I didn't have anything to promote. So
you're promoting your knowledge anyway. But if you want to add this to that, please.
So we Filecoin Foundation. Our mission is to support the Filecoin ecosystem, and we give grants to developers. We run the Filecoin Plus program, and I would encourage your audience to check these things out. Something else we do is education. So we have developer advocates that help software engineers building on Filecoin IPFS, and are writing tutorials all the time. We're running a course starting July 11th. It runs for 4 weeks. And it's going to cover, in much more depth, some of the things we've covered here today. We'll spend a week on Bitcoin, a week on Ethereum, a week on Filecoin IPFS. And you'll notice throughout the talk, I kind of talked about how, Bitcoin is, all these blockchains are open and transparent. Well, that's something that's interesting too. You can actually look at every wallet address, look at how much crypto is in those accounts, look at the whole history of the transactions. And so the fourth week will be a little bit of data science. We're going to be focusing on some interesting applications in this class, and actually one that ties into Sean's most recent question. So the assignments the students will do They'll build a voting machine on Ethereum with anonymous voting, which is a really, really interesting use case. I think one of the most consequential. They'll build their own NFT pet store. They'll be writing both ERC 721 and ERC 20 token contracts, so both non-fungible and fungible token contracts as a part of that. They'll do a data science lab, and then they'll build on Filecoin IPFS a decentralized version of Uber, like a rideshare. And, you know, our hope is that each of these assignments shows something interesting about the blockchain. Certainly with the rideshare, it'll show what it's like to build on a decentralized platform instead of a centralized, instead of with centralized servers. With the voting machine, you know, this is kind of a record, you know, a record storage use case, naturally, Sean. But you know, I think one of the most promising aspects of blockchain, and I think maybe we could close with this, but and naturally, I encourage everyone to go to corise.com. That's CORISE.com, and look for our course. It's called Web3 Applications and Filecoin IPFS, and I hope everyone will join us on July 11th. But you know, maybe to close it out, I think, you know, this record keeping is certainly one of the most compelling use cases of blockchain. Here's why. You no longer need to have the vendor and the owner of information to be the same person or the same entity. What do I mean by that? Well, let's take an example of a university. Let's say you went to university and you became an attorney or a doctor, but then a war came to your country and your university was destroyed. Well, where do you go right now for your credentials? Well, you contact the university and have them send your transcripts, or they send you a letter saying, yes, you graduated from here. But if the university no longer exists, do your records disappear too? That's the question. With blockchain, because of its immutable nature, because of its open nature, at any time, a wallet can represent that university. And that wallet can actually, you know, more or less accredit another wallet, let's say it's a student's wallet, with their credentials, with their degree, with their transcript, so that even if the university no longer exists, we know that at that point in time, that university was legitimate and it was issuing these credentials, and this wallet has this credential, and that's all this person needs to show. And so more or less the vendor, being the university, no longer needs to own the data, being the transcript. Now a different wallet can own the transcript, and we know it's legitimate because of you know, the mining process, the open nature, this, that, and the other thing. So there are a lot of very interesting use cases. I think this identity record-keeping use case is one of the most compelling, and certainly one that you know, we hope to see. We've seen a lot of projects related to that, but certainly we hope to see more. But anyway, voting will be the record-keeping use case that we study and build together in the CoRise course. So we hope everyone joins us for that. So
Super cool. Way better than reading a book and answering a bunch of questions in an exam.
yeah, there's no exams in this course, I can promise you.
That's cool.
No, and the use cases are many, I would imagine. And I know it's not on the blockchain, but we already get our tickets in our wallets, right? To travel, things like that. So why not get our degrees that we can, I presume, even show the courses we took and the grades we got and that support the degree, right? So there's actually extra detail in there. If we can put all that on the chain too, we have even more information to share. Speaking of share information, everybody check out corise.com. Join Robert and crew for all the learnings there on blockchain and the coins and everything that's going on and the use cases that they support. We'll include notes in our show here for well, certainly to connect with Robert on social media and through the foundation and on the course, and anything else that Robert thinks would be useful for folks listening today. And of course, on Audio Signals, we talk about anything and everything on and off the blockchain. It could be music on or off the blockchain, food on or off the blockchain.
And you know what? Everything, the more I get into understanding the blockchain and the smart contract, I can see the application to pretty much anything we do in our life. I mean, we live a digital life.
I've heard stories of authenticity of funny enough, years ago, authenticity of baby formula in China. It was a huge use case.
Yeah, and for the record, I'm not sending you a Bitcoin.
I earned 200 Ethereum.
I know, you just got that. Go figure. Yeah. Bet against Ferrari. Are you kidding me? No.
If it gets me 200 Ethereum.
All right, Robert, thank you so much. Thank you again. Shout out to the Mentor Project, a great organization, and proud to be part of it. And Robert, anytime you want to come back, have another conversation, always welcome. I really love the way on how you present this complex matter and make it understandable. So thank you so much.
Thank you, Marco, Sean. It's been a pleasure, and thanks for indulging me.
Blue Lava is the first business platform for CISOs to manage their security program. Blue Lava guides security leaders to effectively measure, optimize, and communicate their security program with confidence and ease in one platform. Learn more at bluelava.net.
Nintex is the global standard for business process management and automation. The Nintex platform helps their clients accelerate progress on their digital transformation journeys by quickly and easily managing, automating, and optimizing business processes. Learn more at nintex.com.
We hope you enjoyed this episode of Audio Signals. If you learned something new and this podcast made you think, then share itspmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society, and some even beyond that.